Let's get started so we're not late for lunch, right? Nobody likes that. First off, smile. So I can prove to my colleagues that I was working today. Thank you. Perfect. Monitoring of your services or microservices or whatever you have, we don't really care about that. Let's jump right into the topic. I work for Elastic, the company doing Elasticsearch, Logsearch, Kibana, Beats, all the open source products. I'm part of the infrastructure team, and I always say this is a Unix pipe. I kind of pipe that into developer advocacy. So I do lots of talks about all the goodness we do. So let's see what we have here. This was kind of the starting point of this talk, the tweet that once you start with microservices, every outage becomes more like a murder mystery. Because it's so nice, you have everything so distributed, and it's so hard to find what is even going on. And we do have quite some components how to monitor stuff, and it's actually quite easy trying to keep the overview of what is going on. So that is kind of the starting point. So the idea is really to monitor and log all the things, everything we have in our system. So just a quick show of hands, who's using all the latest shit? Quite, I don't know, microservices, highly distributed, whatever, hard to monitor. Yeah. So how do you log and monitor? Just who's using our stack already? Elk, Elastic-Stack, okay, that's a few. Yeah, and then there are lots of other options. But I'll show you what you can do kind of with the latest versions, what we have. So we will use a really simple app. I'm just using Spring Boot, but it doesn't really matter. It's just about something quick and easy to write, so you can do some REST calls, basically. I'm not doing anything complicated. So I would say it's stupidly simple. I'm not doing any load balancing, auto-discovery, or anything, because that is not really core to the problem of the logging and monitoring what we do. I'm just showing all the pieces of information kind of we have, and how to collect them, and how to see what is actually going on. So yeah. Those who haven't used Spring Boot, basically you get a curated list of all the dependencies you can use, and then it's just a few lines of code you put in, and it does everything for you. If anybody has questions for that, we can talk about that in the lunch break, but yeah. Let's skip the Java code for now. I actually run that all on the cloud, and you will need to interact with it, because you will generate the traffic that we're monitoring. So I'm using AWS Lightsail, also because it's kind of the hottest shit on AWS. Or like it's their cheap virtual private service, and it was kind of the easiest to use. I'm just using Ubuntu, but it doesn't really matter. And yeah, that is kind of the infrastructure we want to monitor. And since we also have a cloud offering, I'm storing the Elasticsearch and Kibana part are using our cloud. Yeah, and that is generally the stack. We won't really use Logsearch today. We use Beats, our lightweight agents written in Go, so you have native binaries. They will collect the information, forward it into Elasticsearch, which will store the information. And then Kibana can, yeah, you can query stuff, you can visualize it, you can graph it out. We have dashboards, you will see that. So kind of those three components is what we will cover mainly. Generally, I'm using Terraform and Ansible in the background. I'll push the code to GitHub later on. But again, it doesn't really matter. So we will package something, we'll deploy it, we'll run it, and then we come to the monitoring part. That is the interesting piece. So let's start off. The rest is pretty much a demo. Let's hope that demo gods are merciful today. So I have, I call it bad jar. It's just a jar or Java application that will consume memory and crash at some point with an out-of-memory exception. Some people may say this is a kind of the default behavior of Java. Yeah, it's like 2 lines of code, so that is very easy to write. So let's simply start that. So I'm setting an XMX of, let's say, 512 megabytes, and I have a jar that I have already uploaded, opt, and it's called bad jar. Yeah, and it's running, and it's not doing anything. But we probably want to keep an overview of what is going on our system. So this is Kibana in version 5. We have lots of pre-built dashboards. One of them is for processes. Luckily, we can search for that. And if you type it correctly, you would even find it. And here I have two servers I'm monitoring. You can see, yeah, okay, we have some number of processes running. And here we have, this is the CPU usage, and this is the memory usage. And you can see suddenly something weird is going on here. We have this pink spike here. And when we hover over that, we can actually see, oh, it's Java. So whatever is going down on the system level of your system, we have metric beat that can collect stuff like top or metrics from applications. I'm just relying on the top information basically here. So you can see CPU is, yeah, I'm using less than 1% here and less than 1% here. Not much going on here, but there this yellow, this pink spike is going on. And when you don't always want to refresh your page, we can also change that to be auto-refreshing. I hope my process is still running and hasn't out of memory yet. And when we scroll down here, and you can see, okay, it just crashed. Because you really can see the spike here, and now my memory usage has gone down again. And when I get back to the shell, yeah, you see, standard Java behavior, I got an out of memory exception. But thanks to Kibana, you could really see, okay, something bad happened here. And then you can dive in and see like what was actually going on and what was the root cause of that. So that is the metric part. That's not interesting yet. So let's get started with our application. So I have a very simple Java application, which I will just run on port 80 sudo java jar opt, and it's called front end. But actually I should start the monitoring component in parallel, java jar opt zipkin. Okay, we'll get to zipkin later on. Again, this is also a Spring Boot application. You can see that is basically what Spring Boot does. It has quite nice logging output. You can see syntax highlighting, and at some point it will tell you, yeah, process is running, it has been started, it's running on that port. We'll get back to that later on. Now I can actually start my front-end application. And that should start up, yeah, also in half a minute, and at the end it should say I've started myself on port 80. Yeah, that looks good. Bound to port 80. And now we can see what is going on the network layer. So we have something called packet beat. It uses the same library as Wireshark, but running Wireshark in a distributed environment is always a pain in the ass. So we kind of do that for you. We collect the information. We just read the information from the network header. So for example, we know, okay, this is HTTP. This was the request. This was the response. The whole thing took, I don't know, 100 milliseconds. The response code was a 200, and the URL you hit was foobar. So let's open up the dashboard. And there shouldn't be any requests right now. So we haven't done any requests. And now you can start your interaction as well. So the whole thing is available as frontend.xera.net/good. That will generate it, or should generate the 200. And if you run that, everybody gets their phone out. And you will get 200. I hope so, if you do that. So frontend.xera.net/good. The Xera part is, by the way, a rot 13 of my last name. So those who were back in the good old days when rot 13 was common, yeah, that's where that name comes from. So if you hit good, you should have some traffic. And when we switch to that dashboard, you can see, okay, we've got lots of requests. So we got 59 requests for good. Yeah, we had some fav icons. Then somebody hit DD. Yeah, we have a few 404s. That is also expected. And you can also trigger an error that is called bad. And that just gives you the default white label error page. In the background, I just throw a runtime exception. So it just generates whatever Java exception happens. But it is a 500. If you hit that a few times, And auto refresh is on. Then I assume, yeah, haha is not available. Then you can see, okay, we also got 25 bad queries now. And I haven't instrumented my application at all for that. I have just run packetbeat, and it's really just listening on the network interface and extracts all that information from the headers. So you're not really doing any hard work or instrumenting your application or server or anything. You pretty much get that for free. So you see how many requests you had, what your top URLs were, good, bad. Yeah, fun with flags. You're not a typical German audience because you're not doing just what you're being told, like good and bad. Like, yeah, at previous talks, I had people write me kind of messages here, like great talk, shit talk, whatever. So yeah, you can kind of abuse that to see whatever message you want to have pop up. Then we can see, okay, these are all the error codes we have. And down here, we also have a list like, these are my top URLs. And then you can dive in like, what are my top URLs? Or also, where are my error codes? And if you suddenly get more 500s or 404s on your page, and you don't really know why, this might be something you want to dive into. So yeah, that is probably a good starting point to monitor your service. OK, so we have these 500s. And it was the /bad URL. Now, we would really like to know what is causing this issue, like what is going wrong on my server. And you could log your application like this. And you see that is the exception, my bad, something went wrong. That is the runtime exception I'm throwing. And then you have a long stack trace. And you can start collecting that file and then parsing it. But parsing everything that is multi-line is always a pain in the ass. So we're not doing that. I'm always trying to go the easy way. Instead, since Elasticsearch is storing JSON and handing out JSON again, I'm actually logging to JSON already. So just to, I need a new tab to show you. SSH front, no, not like that. Ubuntu at frontend.xera.net. So I'm just dumping out my logs as JSON var log apps frontend. No, frontend.json, I think, yes. So what I'm doing is I'm using logback. Whatever logger you have, it doesn't really matter as long as you can write out JSON, because then you have it in a structured format already, and then you don't need to parse back all that information. Because if you use these line statements where you have something, yes, you can parse it back with a regular expression, but I guess very few people actually enjoy writing regular expressions. At least I don't really. So this is much nicer. You already have the JSON, and we can just collect that JSON and then search in that JSON. So if we go back to our browser, we can now start discovering data. So we have data in different indices. One of them is filebeat. And this filebeat is actually just pointed at that one log file and collects that log file for us. We throw it into Elasticsearch, and now we can just start searching through it. So the first thing I would be interested in is what is the distribution of good stuff and bad stuff, or what is the distribution of messages I have. So you see I have a lot of errors. Since everybody now hit the error page, we only have errors up here and infos down there. But normally you would have infos and errors and everything like wildly mixed together. What you can then do is, we have really a 50-50 split. That is kind of, good split there. You could filter then down on something you have in that message, but we'll just display one. And you can see, okay, we have the caller, like the stack trace. We see where it actually happened, the process ID, the message. And we could just search freely in here. So I could just say bad. And OK, we had 76 bad requests now. And it would just find everything that contains this bad in the body. So you can just freely start searching in your exceptions. You have the information structured. So you could also limit the search to a specific field. You could say json.class, and then, I don't know, I'm just interested in exceptions from a specific class. Or if you log the IP address, the username, the URL, whatever you log, you could have added it here, and then just limit down to whatever you're searching for. What is the problem? What do you want to actually find? So that is kind of convenient for log management. Who's using tailf for log management? You should be ashamed. No, I'm kidding. Come over to us. We have some nice tools, or many others. Yeah, as soon as you have more than 5 servers using tailf, it's probably painful. I don't know. At least for me, it was. OK, so that is up and running. Now something else we can do. We want to know if my service is available. We have something called heartbeat, and it does just continuously ping your services. It can do ICMP, HTTP, HTTPS, stuff like that. So I have stopped it for now, so it doesn't ping my server all the time. For a change, we can actually look into the configuration file, because it's so simple. Heartbeat YAML. So what I'm doing is, yeah, don't copy my password, but I'll kill the instance afterwards anyway. So this is actually the cloud instance where we store everything with username, password, and kind of secret ID. And this is my pinging. So all I'm doing is I'm saying frontendxera.net on port 80/good, hit that. Every 10 seconds with a timeout of 10 seconds, and expect a 200 back. And if there is not a 200 coming back, it will be marked as down. So I am starting the service now. And again, we have a pre-built dashboard. So I'm lazy. I didn't build anything myself. I'm relying on my colleagues. So we're interested in the heartbeat dashboard. And you can see it is up and running, so that should be good. You can see, yeah, it doesn't yet have how long it took, but if it has been running for some time, it will tell you how long did the round trip time take? How long did, if you have TLS, how long did the handshake take? How long was the HTTP round trip? And how long did it take to connect on the TCP level? Oh, so yeah, it's appearing. We don't have lots of data, but you can see, OK, the round trip was there really high, and it has now fallen quite a bit. So we can let that run. You can see how long was the distribution of HTTP requests. Depending on how long they take, like that took 100 seconds, that is like forever. Most of them should be down here, so they should be much faster. Yeah, and if you let that run, you will at some point see, OK, how long did my requests take until I get a proper response back? And now everything is good. Let's kill the service for a change. And if everything works, it should turn red in like 5 seconds. Yes. And you can see, OK, of the events we had, suddenly here you can see the spike. Oops, it's going red. If you have multiple services, you will have a percentage of all the stuff you ping and what is available and what is not available. And if you have that up on the dashboard, you can then react to it. Or you can just put up the response times on the dashboard and see if suddenly your response times are not where you want them to be. You should probably step up. OK. So that we don't generate too many requests. No, that's the wrong window. I will stop my heartbeat again, so we can focus on something else. I am starting my front end again. And one other nice attribute of Spring Boot is that it automatically exposes some endpoints where you get, as JSON, which is very convenient for us again, you get some information about the service as JSON. So what we support is, frontend.xera.net/health. Yeah, that is what the health endpoint gives you. So if you don't want to ping it like from an outside service, you can just use this endpoint and it will tell you up or down if something in the app is down. It will tell you, yeah, the disk space currently. And it has another endpoint which we can currently use, that is metrics. And there you have stuff like how much memory is being used, how are garbage collection doing, like all the stuff that Java applications are interested in. And we didn't write it, but somebody from the community wrote the beat to actually collect that information and store it into Elasticsearch. That is called Spring Beat. So for Spring Boot, there is Spring Beat. Let's quickly change to that directory. Yeah, so that is the GitHub name of the guy who wrote it, and the project name is Spring Beat. And we can simply run Spring Beat now. And the Spring Beat is, again, pretty much configured like the Heartbeat configuration. It will just every 10 seconds, it will collect the JSON information and store it into Elasticsearch for us. And then we can, there is no default visualization, but we can simply go to Discover. We have Spring Beat here, one of the indices of the information we collect. And it didn't collect anything yet. Are you running? Please be running.
You still have a search on bad.
Ah, yeah, thank you. That is the common mistake. There is no bad in Spring Beat, unfortunately, or fortunately. We can also, let's get rid of that field first. We don't need you. Let's go back to Spring Beat. And there you see we have the health information, and the request next to it should be stuff like the garbage collection. So what is the heap size you're using? How much memory is available? How many HTTP 200 requests have you served? All of that information. So you have all of that stored. There is no pre-built visualization for it yet, but you could easily graph that out, like build some bar chart, pie chart, whatever, based on, for example, on the heap usage. And if you hit more than a certain heap usage, you know, okay, something is maybe going wrong with my Java application. Like heap can always be tricky with those. So yeah, if you're not using Spring Boot, but you're exposing your own JSON information, it should be pretty much trivial to collect that. So we provide a base library which connects to Elasticsearch and just handles that part. You only need to kind of collect the information you need and put it into the right fields, and then we will store it in Elasticsearch, and you can graph it out later on. So that should be very easy. So whatever JSON information your application exposes, you can very easily collect that and then store it. OK, and then we want to see what traces we have. So if you want to see that yourself, but you don't have to, it's on a mobile phone, it's probably a pain. So let's see, let's go to 1330. So let's see in the last hour all the traces we had. This is Zipkin. So there is Sleuth, the detective. That is part of the Spring Boot application. And whenever you get a request into your system, it will attach a unique ID to that request. And that, even if you call remote services and everything, that ID is still kept on that one request. And we can then collect that information, and based on the ID, we know what kind of where did the request go and how long did it take. And then we have Zipkin. Zipkin is the visualization part for that. So you can see most of our requests have taken very little time, like we had microseconds when we called something. There's just the visualization part. So somebody tried to call no, that's not the, where did that request come from? That is interesting. let's limit it down to good. Okay, that is a regular request. It stripped out the URL, but it knows we had somebody hit good, and it took, I don't know, 150 milliseconds for the entire thing to get around. But that's not that interesting. It's just a single call. What we can do instead, if you still have your phone open, you can do call/call, and that is actually triggering one request internally and then triggering another REST call in the background. And I have put a random sleep in there of up to 2 seconds, so you can actually see that something is slow in your system. Like when you call it a few times, it will take some time, and yeah, it will always print out hello world, and sometimes the call is slow, and sometimes the call is fast. And that is another very nice attribute of distributed systems that is very hard to know, like something is slow, but what is actually slow? What is slowing down my requests? So if I and you have done some requests now, we know that we should have calls somewhere in there. No, not cool. I probably need to find traces again. And we can switch that back to all because those will be the slowest anyway. And you suddenly see, okay, ooh, something took 900 milliseconds. That is really slow. Let's see what is going on here. And then you see, okay, something called call, which took 902 milliseconds. And then it called further home, which took 2 milliseconds. So obviously the sleep or the slow part was on the /call, and the call behind it, which was /home, that was actually fast. And if you have lots of cascading calls, you would have all the calls down here, and you could see graphically like how long is each one of them taking. So it is, once you have added that to your application, it is very easy to pinpoint like what is causing the slowness in the system. Otherwise, with a distributed system, it's very hard to see where the slowness is actually happening. Okay, and that was pretty much the demo. So just to quickly elaborate on that, what you will have is I've enabled that in Spring Boot. Spring Boot has an integration for that. And you will get logs like that. So first, something is the call thing you've called is calling home, and there's you called home. So those are the two methods you're calling. And then we have 3 elements in there. So first off, I've named my application. So you've called the front-end application. Then we have the trace ID. That is always the same over one call. So once you do the call or the request against the /call, that ID will always be the same for all cascading calls behind the scenes. But that span ID will be different. That span ID is basically one unit of work. So it's kind of one method call further. And based on that, you can see which one of them is actually the slow one. And then we're sending that to Zipkin, which is the server to collect the information. And it supports an Elasticsearch backend as well, so you keep all the data in Elasticsearch. And it has this visualization part where you can actually see these cascading calls. Yeah, that was Zipkin. And there is a simple Zipkin package you can get from Spring Boot, and there's nothing more to do. It's just another jar you run. So stuff I would love to see, like when I did that talk, something that would super nice is if we had annotations in Kibana, where you could actually annotate like I deployed something here. And then you see, suddenly my 500s go up, or oh, my response times go up or down. That is super helpful if we had that. There is an open issue. Not sure when we will get that. Something else I would love to see is currently for our cloud, we don't have an API, so I always need to create that instance manually. But yeah, as soon as we have an API, we want to integrate it into Terraform again, so everything can be automated. Yeah, what are you missing? But talk's pretty short. Come to me afterwards if there's anything you think like that would be a great idea, what we don't support at the moment. We are always interested in ideas around that. Yeah, to conclude, we've seen, we had very simple setup. We had just 3 instances in the cloud. We saw system metrics. where we collected basically the top information, like CPU usage, memory. We did network packets. We monitored the uptime of services by explicitly pinging something and seeing how long does the service take to respond. We collected the application logs, which we dumped out to JSON because it's way easier to collect afterwards. We have the application metrics. That is mainly what the Spring Boot metrics and health endpoints are exposing, so you can collect that. And you can easily do request tracing if you have some trace that is the same over all your calls. Yeah, I think we have like 5 minutes left. I do have stickers. I need to get them out. So if you want to have Elastic stickers, come to me afterwards as well. Are there any questions? Everybody wants to go for lunch. You can say it. It's OK. Yeah, if you have questions, come to me. I'm happy to answer them. Thanks.